Hello, my name is Alan Johnson. I am an engineer and I invented the J-Drive engine. The J-Drive engine is going to be a very big deal. Here is the story of this wonderful new invention. The story begins over 150 years ago with a very famous man. His name was Nikolaus Otto. Nikolaus is famous for inventing the modern four-stroke engine. But first he invented an engine that does not use a crankshaft. The crankless Otto-Langen engine was far more efficient than competing crankshaft engines of the day. It won a coveted industry prize as the world's best engine. Thousands were produced and used in factories all over the world. Here is the basic principle of the Otto-Langen engine. A one-way clutch locks the piston rack to the drive shaft during the power stroke. The clutch spins free during the return stroke. A spring is shown here for powering the return stroke. But in the Otto-Langen engine, gravity is used instead of a spring. So why was this design abandoned? The problem is metal fatigue in the clutch. A one-way clutch today lasts fewer than 1 million lock and unlock cycles before fatigue failures set in. But modern engines reach 1 million cycles in just a few hours. The problem is due to the exceedingly small contact surfaces in today's clutch technology. The obvious solution to this clutch problem is the wedge clutch. When wedges replace rollers, the contact areas are greatly enlarged. Metal fatigue is completely eliminated. I've studied all of the many wedge clutch designs on file at the U.S. Patent Office. None of them will work in a J-Drive engine, and many do not work at all. You see, the friction physics needed to make sure a wedge clutch works is very tricky, and you have to know what you're doing. After years of effort, the result is a clutch that is purpose-designed to operate trouble-free in the J-Drive engine. By the way, the USPTO very quickly awarded the J-Clutch patent. The J-Drive engine is far more sophisticated than Otto's crankless engine. The J-Drive is an internal combustion free-piston engine. As with the wedge clutch, numerous attempts have been made to invent a practical gasoline or diesel-fueled free-piston engine. The most successful is the Chiron engine. The Chiron is a hydraulic pump manufactured in Holland and used to power forklifts, but the Chiron does not produce much horsepower. The J-Drive patent lists 10 problems with current free-piston designs. The patent reveals practical solutions for each of these 10 problems. Problem 1, for example, concerns engine speed. Free-piston engines run at just one speed. Think of an engine that will only run at 1000 RPM. No faster, no slower. The gas pedal has no effect. Big problem. A free-piston engine's speed is controlled by the bounce chamber spring constant. Whatever that spring stiffness is, that's the engine speed. I solved this problem with a nifty little invention. A sleeve valve surrounding the bounce chamber. Rotate the sleeve and the spring constant changes, and the constant can be precisely adjusted. It is a simple and reliable mechanism. It's like the butterfly valve in the throttle body of an engine carburetor. The U.S. Patent Examiner highlighted this solution when granting the J-Drive patent. Greatly reduced friction is the most obvious advantage of the J-Drive engine. Friction eats up more than 10% of the power produced in a crankshaft engine. The J-Drive cuts friction by nearly 80%. But an even greater advantage of the J-Drive is its stroke length. When it comes to efficiency, short stroke lengths are very problematic. There is a reason why short-stroke engines are the norm in the automotive world, but let's not go there now. Outside the automotive world, all engines have stroke lengths as long as possible. Take a look at this big boy. It is one of the most powerful and efficient internal combustion engines in the world. Its stroke length is 2.5 times piston diameter. Here's another high-efficiency marine engine. Look at the length of this combustion chamber. It is 4 times the length of piston diameter. But in a crankshaft engine, you have to have a mechanism called a crosshead to get these long stroke lengths. The crosshead is huge and heavy. It is impossible to put in a small transport engine. The J-drive engine does not need a crosshead to achieve long stroke lengths because the J-drive does not have a crankshaft. This allows the J-drive to implement an Atkinson engine cycle. The Atkinson cycle is known to increase efficiency and to greatly cool down exhaust gas temperatures. The J-drive will be a very cool running engine, much less waste heat. You can help bring the J-drive revolution into reality. Social media is a powerful force. Please help by spreading the word. Share the friction physics videos with your friends.